After the last video, I was interested in how water flows through the earth, which means I was happy to find out that the aquarium was being emptied, so I could demonstrate how the water table works. Alright, let's go there now. And here it is. Alright, first let's get the gravel in. Alright, and now let's see what happens if we add water to the gravel. So you can see that the water travels down through the gravel and into the empty space beside it, being pushed down because of gravity. But what is going on here, and how do we define it? You see, within a rock there is two zones. There is the saturated zone, where water has filled up the free space in between the rock, and the unsaturated zone, where within the rock the free space is made up of water and air. Where the saturated zone ends, this is called the water table, and where the surface intersects with this water table, it creates surface water. In this case, you get water coming in through the ground, and this creates a gain in river system. In our world, this is commonly the main source of water for rivers and lakes. If the surface water, however, does not intersect with the water table, then this creates a losing river. In this case, unless there are further inputs, then the water will slowly seep into the ground over time, and you lose water from the system. And this water table is highly dependent on what inputs and outputs you have. If you increase the inputs, for example have more rain, then the water table will rise over time. So in the dry season you can have a low water table, and this can change a gaining river into a losing river. But inputs don't just depend on rainfall. Many surface processes also affect how water goes into the table. The amount of water that gets into the ground is also affected by vegetation, which can intercept 40% of the rainfall in forested areas. Much of it also evaporates before it hits the ground, in the air or getting stuck on leaves. It can also move along the surface if the ground does not absorb it fast enough, and thus travel to a lake or a river as overland flow. What determines if water moves along the surface or the ground is the porosity, the amount of free space within the rock, or the permeability, the ease with which water can travel through the rock, or the material. Some rocks have a very low permeability. If a rock is impermeable, then it's called a confining layer, and it stops water from flowing through. This is good to consider when building dams, as low permeability rock stops as much water from escaping. Pumping water from the ground, as many towns do, also affects the water table. When water is pumped and used for crops, a lot of it evaporates, and this can lead to a decrease in the water table. If you pump enough water, then you can potentially disrupt other systems. Rivers and lakes can lose their water and dry up. Subsidence or lowering of land can also occur, as when water is taken out of the system, grains compact and take up less space. Once this process occurs, it often cannot be undone. It's a careful balancing act. If you want water use to be sustainable, then your inputs should be at least as big as your outputs. So it's important to manage groundwater, as it has a lot of influence on water supply, rivers, lakes, and the environment. Till next time, thank you for watching. Hi, I just finished editing, and I want to let you know that I'm doing this as part of a class called Science Communications on the Web. So if you could, please leave me some feedback so I can improve and get better. Or alternatively, you could also look at some other students' projects, such as right here and right here. Till next time, thanks for watching.